Hello, welcome to today's class. What we are looking at today is the part 2 of memory units. I believe that in the part 1 we're able to establish the fact that the memory unit deals with storage, is the component of the computer system that deals with storage. So we shall build on that knowledge by looking at how that is being achieved in the computer, right? Okay, before we can understand that, it's good to compare auxiliary storage devices because we store large volume of data using auxiliary or secondary storage devices. They are grouped into three classes. They are either magnetic, optical, or solid state auxiliary storage devices. Now, they have various technology they use for storage. The advance of them is called the solid state, followed by optical and then magnetic. Now, magnetic is where your hard drive belongs to, and mostly when the hard drive is functioning, you hear sound, right? So when it's spinning, there's a magnetic component that is built into it. Optical deals with light. That's where flash and then DVD belongs to, right? And like I said, solid state is the more advanced of all of them. Okay, now in terms of hierarchy, registers happen to be the smallest storage medium, then followed after the registers, we have the cache, which is bigger, and then we have RAM, and then we have hard drive. So that is how they occur in ascending order. And don't forget that data is actually stored in binary form within these storage devices, and is transported from the device, that storage device, to the CPU through what is called a bus. And a bus should have a bus width and a bus speed to regulate how data is being moved. Okay, like we said before, just like any other measurement we do, we measure data that we store in units. So no matter how much data is, you can measure it, and that is why a small memory card can store so much data, because that data is broken down into smaller quantity so that it can be stored. Smallest of them all, the smallest unit of storage is called bits, and is short for binary digits, and it consists of just 0 and 1. So after bit we have bytes, then we have kilobyte, we have megabyte, and then it keeps on increasing in hierarchy like that. So that means a gigabyte is more than a megabyte, megabyte is more than a kilobyte. Now, more to this hierarchy issue in terms of unit of storage. So a bit consists of either a 0 or a 1 digit. So it's either 0 or 1, and that is this elementary or the basic format in which data is being stored. So, but it's too small. Then after bit we have what is called nibble. So nibble is like doubling a bit. So doubling bit. So when you have 2 bits, when you double it, that will give you 4 bits, and that will mix up a nibble. After the nibble we have what is called a byte. Now, most at times we are familiar with byte. You hear things like kilobyte, megabyte, and the rest of them, because byte is a bit larger and it's easier to comprehend than the binary digits or the nibble. And a byte is just nothing but 8 bits of data. And then after byte we have kilobyte, which is 1,000 bytes, and then we have megabytes, we have gigabytes, terabyte, petabyte, and the biggest of them all in terms of measurement capacity is called zettabyte. Meaning, for data to be measured in zettabyte, it has to be a huge data. It's so huge, so huge, so huge. So the smallest unit of storage, don't forget, is bits, which is binary digits, and it consists of either 0 or 1, and then you keep on ascending in terms of storage. So no matter how big a computer is or small a computer is, what we are saying is that the smallest units that we can store data and the CPU can understand is the binary. Is that okay? Okay, so if that is the case, that means conversion happens within the CPU in order to obtain, within storage devices, in order to obtain higher values. We have to do some kind of conversion. So that means we can convert from megabyte to gigabyte, from gigabyte to terabyte, and so on and so forth, using certain values. So since a byte, 1000 bytes gives you kilobyte, so that means ordinarily I should have 1000 bytes in a kilobyte, and then I'll keep on getting that value. So we'll stop here for today. Thank you. Have a nice time.